Hi guys, we're going to continue with dividing using the box method. Now, I don't know if you noticed, but in that first video, everything worked out really nicely. We got to the end of the problem and we were like, I need this number and this, oh, they're already matching. So that was like fantastic. But that doesn't always happen, right? Not everything will divide evenly. And so in this video, I'm going to show you what it looks like when you get a remainder, when it does not divide evenly, and when you check that last number and it doesn't match. Okay, so that's what we'll be doing in this video. Here's our first example. I tried to color coordinate everything the same as the first video. So we've got our blue number, which we've been putting inside the box. And then we have the black divisor, and that's what we've been putting along the left side. Just like in the first video, we can rewrite this as a multiplication problem. So we're thinking of this not as division, but as like missing product, right? So 2r plus 1 times what equals 8r to the third minus 10r squared minus r minus 4. Okay, so just like we were doing in the first video, I'm going to draw a box, and I have a binomial, 2r plus 1, so I need it to be 2 along the left side. And then again, I don't really know how big my box needs to be. I can always add on if I need to, but since the top of the fraction had 4 terms, I'm going to go ahead and make it a 2 by 4 box just to start with. Okay, it's a good starting point, and if you need to add on more later, you can add on more later. The denominator, the 2r plus 1, goes along the left side. And let's get started. So we're going to take our first term from the numerator, the 8r to the third, and we're going to put it in the first box right here. Then we ask ourselves, 2r times what will make 8r to the third? So 2 times 4 will make 8, and then r times r squared will make r to the third. This 4r squared also needs to be multiplied by the 1. So 4r squared times 1 is 4r squared. Next, on the diagonal, we're supposed to have like terms. So I do expect there to be an r squared up here. And when I combine these like terms together using adding, I'm expecting it to turn into this minus 10r squared. So the question is, 4 plus what is negative 10? And the answer is negative 14. 4 minus 14 will make negative 10, r squared. Okay, now this 2r had to multiply by something to make that negative 14r squared. So 2 times negative 7 will make the negative 14, and then r times r will make r squared. So negative 7r goes up here. Next, I'm going to multiply the negative 7r times the 1, and it's still negative 7r. And we do it all over again. So if you are feeling pretty comfortable and confident with the box method, I hope that this dividing using box method is not too tricky. I know it's a little different than what we've been doing, but all of the concepts are the same and all the math is the same. So we have on the diagonal, we should have some like terms, right? So the negative 7 plus something should make, and this time it's the r. So I'm going to look at the r from my numerator. So negative 7 plus what makes negative 1, and that would be plus a 6. Negative 7 plus 6, or 6 minus 7, makes negative 1. 2r times 3 makes 6r. 3 times 1 is 3. Now here's where it's not going to work out nicely. So that was like the whole point of the second video is we're going to have a remainder. There's going to be leftover stuff. So 3 can have a diagonal up here. And those two together are supposed to combine to make this negative 4 from the end of the numerator. Now, it doesn't match up in this one, right? Last video, this was negative 4, and we were like, yay, we're done. So this time I do need to actually think of something to put over here. So 3 minus 7 is negative 4, right? 3 minus 7, or negative 7 plus 3. So I have this negative 7. Now, when I see negative 7 here, I can't do 2r times something to make negative 7 because this has an R and the 7 does not. So at this point in time, I'm going to stop. I'm going to say I'm done. And my -7 will be my remainder. So if you have this leftover thing that doesn't work out nicely with your top term, then that's your remainder. And then what we do with remainders is we put them as a fraction at the end of the question. And we just we put it over what the original denominator was, the 2r plus 1. So I'm going to put -7 over 2r plus 1 at the very end. I'm going to throw in some plus signs and we're going to say this is done and this is my final answer. So if you have a remainder, there will be a not so pretty fraction written at the end of your answer. And again, best case scenario, you should have written 4r squared minus 7r plus 3. Over here, you could even do minus 7 over 2r plus 1. If you want to take that negative sign and put it in front, that's fine too. This is my final answer. Let's do one more with the remainder just to make sure we know what we're doing. And I'm going to make this one a little bit bigger of a problem. So you can see, hopefully, that our denominator this time is a trinomial instead of a binomial. So just a little bit larger to work with. I am going to still rewrite it as my multiplication problem. So my denominator, x squared minus 6x plus 9 times something equals my numerator. This time, since my denominator is a trinomial with 3 terms, I am going to make my box have 3 rows going across. And I'm just going to go back to that default. My numerator has 1, 2, 3, 4, 5 terms, so I'm going to make it 5 columns. Okay, and I don't know if that's right or wrong. Sometimes we need more, sometimes we need less. You can always adjust later. But we definitely need the 3 rows along the side so that we can line up our denominator, x squared minus 6x plus 9. Now, this one, we're going to go the same as what we've done on all the other ones. The only thing is that sometimes our diagonals are going to be a little bit longer, so they might be 3 boxes instead of just the 2 boxes. So we'll talk about that. But let's start the same way we have with the other ones. So I'm going to put the x to the 4th in the first box. And then I have to think to myself, x squared times what makes x to the 4th? And it's x squared times x squared. And then you do want to fill out the rest of this column. So once you figure out what goes above the box, you do want to multiply that by everything along the side. So I want to multiply it by my -6x, and I want to multiply it by my 9. Look at how these are also in descending order. So many patterns in the box method. Next, since I already just worked with my x to the 4th, I'm going to work with just my x to the 3rd. So -6x to the 3rd is my one term that I have right now, but it does have a diagonal. And so these two combined together need to equal the -1 x to the 3rd from up here. So -6 plus what makes -1? And it is -6 plus 5, right? 5 minus 6 is -1. And then we do it all over again. So x squared times 5x makes 5x to the 3rd. 5x times -6x is -30x squared. 5x times 9 is 45x. Look at the descending order. Even going the other way, it's descending order. That should always happen. Okay, next in my row is x squared. Now, x squared, the diagonal is a little bit longer. So it includes these 2 that are already there, and then plus this 3rd one now too. So you do want to go all the way across from one corner to the other on the box. Okay. Now, these 3 boxes combined together need to equal -35x squared. So if I combine together the 2 that already have numbers, 9 minus 30 is -21. So the real question is -21 plus what makes -35? So -21 and -14 will make -35. You want to check and make sure that these 3 numbers on that red diagonal add up to make -35. You can always use your calculator to double check it, right? 9 minus 30 minus 14. Okay. All right. Here, we need to multiply by -14. And we can break out our calculator for this part too if we need it. Negative 14 times negative 6x is 84x. And negative 14 times 9 is negative 126. So again, no shame in using a calculator on these problems. Next in my list is the letter x. And so I do already have 2 boxes with the letter x right here, but I do need to keep going with it diagonal and go all the way up to the top. So I would add together 45 and 84, and that is 129. So 129 plus something needs to go down to 120. So 129 minus 9 will get me to that 120. Okay. Now here I'm stuck. This is an x squared over here, and this is just an x to the first. I can't do x squared times something and make it an x to the first. Also, look at this top up here. X squared, x, a constant. I'm not going to be able to put anything else on top. Once you reach that constant number, you can't put anything else on top. Now, there's one number that we haven't dealt with yet, and that's the constant from my numerator, the negative 8 up here. And I also have this negative 126 down here, which is also really weird. My negative 126, I'm going to just go one diagonal just up here because I've decided, because I'm done, I don't need this extra row of boxes. I made my box too big this time. Totally fine. This negative 126 needs to combine together with one number, and it needs to turn into the negative 8. Okay. So that's going to be a positive 118. 118 minus 126 is negative 8. And then these two together are going to be your remainder. So when your denominator is a trinomial, it is possible to have a binomial as your remainder because of our exponents, right? So we had an x squared and an x. You can have an x for part of the remainder. Since these are both the remainder, I'm going to add them together just by putting a plus sign between them. And I'm going to put them both on top of the fraction. I'm going to throw in some plus signs, and we're going to call it a day. This is the answer. X squared plus 5x minus 14 plus this lovely, lovely fraction. Now on this fraction, if you take the negative out to down here, you would also need to take a negative out of here. It's like factoring out a negative sign. So if you want to just leave it negative 9x plus 118, that's fine. Or you could write 9x minus 118 if you want to make this a minus sign instead. You do need to put some sort of symbol right here, separating out your constant and your fraction, okay, so that they're being added together. So that's what you do when there is a remainder. And this concludes our second video.